All right. Hey, everyone, again. Today, we are going to talk about a little bit of notes on a topic called drag force. In class, this has come up, and I always say, oh, don't worry about that, we'll do it later. Don't worry about it, we'll do it later. And now's later. So, drag force is essentially air resistance. We can refer drag force as a velocity dependent force. So if the force depends on the speed that the object is going, we call it a velocity dependent force. So there's multiple ways you can have this. You could have an object just falling. You could have a car accelerating, and you could be taking into account the resistance. What we're going to do is I'm just going to say, here's someone. Gravity is pulling down on them as they're falling, and air resistance is therefore opposing that motion. So we'll call that F, air resistance. You guys don't actually have notes on this, so you can just write this on a piece of paper or whatever. So what we can do is, there's my forces. That's what's going on. If I want to write a equation that explains this motion, we can write a differential equation. We can say differential equation. We can say, well, I know that F equals ma, and in this particular case, we're going to say it's air resistance minus mg. But this air resistance, I can actually say, is equal to bv. So some constant times the velocity. It is a velocity dependent force. So we would have bv minus mg is going to equal negative m dv dt. So we're making up positive bv minus mg, so we're accelerating downwards, so it would be m negative a, so negative ma, and a we can write is dv dt. So this equation right here is the equation that explains what's going on with that motion. So equation that governs this motion. So what we can think about it is the max acceleration is when, or the max speed is when the acceleration is going to equal 0. So we can therefore say the max speed is mg over b. So essentially, we drop this object, the speed starts off at 0. At t equals 0, my speed is 0. As my speed increases, the air resistance is also going to increase, and it's eventually going to get to a point where I am no longer accelerating, so my net force is 0. Therefore, bv equals mg, so my max speed is going to be mg over b. Does that make sense? One more time. At t equals 0, my speed is 0. We just dropped that object. As my time increases, my speed is going to increase, and my speed is eventually going to reach a maximum value where my net force is 0, so my upwards drag force, bv, is going to equal my downwards gravity force, mg. Therefore, I'm no longer accelerating, my net force is 0, and my max speed, we could say, is equal to mg over b. Hopefully that makes sense conceptually. Conceptually, this isn't anything too crazy. Mathematically, though, this can get a little nuts, because a lot of times the questions are going to say, okay, write the differential equation, and then you want to solve for the speed. And solving for speed in this is complicated because we have v on one side and dv dt on the other. So solution of this is done by a trick called separation of variables. Solution by separation of variables. Perfect. So let's rewrite what we started with, our equation that governs this motion, to get rid of the negative sign. So we can say mg minus bv is going to equal m times dv dt. All right, now I want to put anything that has a v on one side and anything that has a t on the other. So I can rewrite this. dt is going to equal m over mg minus bv times dv. So this is what we call separation of variables. All the one variable goes on one side, all the other variable goes on the other side. So we can actually take the integral of both sides to solve this. So on the left side, I'm going to take the integral from 0 to t, and on the right side, I'm going to take the integral from 0 to v. On the right side, I'm going to have to do a u substitution. So we can let u equals mg minus bv. So du dv is therefore equal to negative b, which means du equals negative b dv. So what I end up with, I can pull out the m. Since I have a negative b for my du, I have to put a 1 over negative b outside the integral. So what I end up with, so I still have integral 0 to t dt on this side. I'm going to pull out the m, the integral from 0 to v of 1 over u, because I made mg minus bvu. And then dv, I'm going to make, I need it with respect to u, so I can say du, but in order to make this an equality, since du is negative b dv, I have to put a negative 1 over b out front. Goodness gracious, hopefully you remember your u substitutions. So the left side's easy. The integral of dt is t, evaluated from 0 to t, is just t. On the right side, I've got m over b, negative m over b. And then the integral of 1 over u du is ln of u. So this is the natural log of mg minus bv evaluated from 0 to v. All right, let's put the m over b on one side. Let's put the m over b on the other side so it's out of the way while we evaluate this integral. So we have negative t over m over b is going to equal, so I have to plug in v, so I have ln of mg minus bv minus what we get when we plug in 0, ln of mg minus 0. Cool. So I still have negative t over m over b. And let's combine the natural log rules. ln of mg minus bv over mg. So now let's pause. What am I trying to do? Remember, I'm trying to solve for the speed. I want an expression for the speed of this object as it's falling. So in order to solve for v, we got to get rid of the natural log. In order to get rid of the natural log, we're going to raise everything to the e power. So on our left side, we're going to have e to the negative t over m over b. And then on the right side, sorry, we have mg minus bv over mg. All right, we're trying to solve for bv, or sorry, we're trying to solve for v. So let's start rearranging this. I can therefore say BV is equal to, just multiply the mg up and then bring it to the other side. So I'm skipping some steps. mg minus mg e to negative t over m over b. So close. Divide by b, and I'm going to pull out the mg. So we have mg over b times 1 minus e to negative t over m over b. Yay, we did it. So here is my expression for my velocity. Things you should notice. Let's look at 1 minus e to the negative t over m over b. That's always going to range between 0 and 1. The max speed we're going to have is when that equals 1. So the speed max is going to be mg over b, which is what we talked about earlier. So this is my v max. This right here is always going to be between 0 and 1. So essentially, it's the decimal percent of Vmax. Depending on what that equals is going to be how close to our max velocity that we're at. So if we want to plot this to hopefully make it make more sense, I'm going to rewrite this. We're going to say, let's say that, I want a new color. Let's go pink. Let's say that our velocity as a function of time, we know is going to equal to mg over b times 1 minus e, I'm going to say negative t over tau. This is going to simplify it a little bit. We're going to say with tau is equal to m over b, and we're going to call that essentially one time constant. Defined to be one time constant. So if we have t equal to m over b, so when t equals m over b, we get, or you get, 1 minus e to negative 1, which is 0.632. So if I'm plotting this, here's my v, here's my t, velocity as a function of time. There is some max velocity. Here's my v max. V max. And we're going to start off at 0, and we're going to increase as my time goes on, and eventually I'm going to reach my V max. When my time is one time constant, so when t equals tau, we are at approximately 63% of Vmax. So this is 0.63 Vmax. If my time is 2 tau, I'm at approximately 86% of my Vmax. This would be 0.86 Vmax. So I increase until I eventually get to my max velocity, which is mg over b. That's when my net force is 0, my acceleration is 0, I don't go any faster. This is my crazy equation to govern it. Essentially, we start off with our differential equation, use separation of variables to get to the velocity function as a function of time. Phew! All right, that was a lot. Hopefully it made sense. I really like doing math, so hopefully you followed. If something got lost and you didn't understand, just let me know. But fingers crossed you were somehow able to follow that. All right, sounds good. I'll talk to you guys later. Bye.